Hey everyone, I'm Jordan. I'm from the biostats class at St. Cloud State. I thought I would maybe just put up a couple of videos in case you're gone a day or two or whatever, or you just can't follow along with the teacher, which, let's face it, is pretty much every day. So I'm going to kind of summarize his lessons that he goes through. Maybe it'll be a little bit easier to understand. I think based on our last test, we could all use as much help as we can get. So we never really went through this in class, the whole point of why are we using normal distribution, what is a z-score, why do we give a shit. This is what we consider to be a normal distribution graph of data. As you can see, it's symmetric, it's also bell curve shape. So this is what we consider to be normal distribution, standard normal distribution. What we never really talked about is there's a rule or a theorem that says, it's called the 68, 95, 99.7 rule. And basically what that means is that as you go one standard deviation either above or below the mean, which is at 0.0 on the chart, you're going to get 68% of all your data to fit under that curve, which means you're going 34% of your data if you go above, and then 34% if you go below. And also if you go 2 standard deviations below or above, you're getting 95% of your data, which means that if you go above 2 standard deviations, you're getting 47.5% of your data under the curve, and if you go below, you're getting 47.5% under that curve. And then if you go 3 standard deviations out, you're getting 99.7% of your data to fit under that entire curve. Which means that if you go 3 standard deviations above, you would be getting 49.85% of your data, and if you're going 3 below, you would also get 49.85% of your data. And then if you go all the way out to 4 standard deviations above or below, you would get all of your data, which means in either direction you would get 50% of your data under that curve up to your mean. So what does this mean? How do we find this? Well, we can find this using z-scores, which most of you already know how to find. We kind of talked about it in class. We're already starting to use it, but we never really talked about why we are trying to find it. A z-score is defined as being x, some value that we're trying to find, subtracted from our population mean all over the standard deviation of our data in an equation that looks like that. So in problems you might see it, they might give you, let's see, parentheses. They might use this kind of weird notation. Let's see, I'm just going to make something up really quick. Okay, so you're going to see it written in 2 ways. In the book and online, you're going to see the bottom one, which is where x, some value that we're trying to find, is related to n, our normal distribution of our data, and in parentheses, the 100 is our population mean, and 8 is our population standard deviation. So the top one is what Dr. Leonard Oniyah, however you say his last name, does it. Basically, the population mean is still the same as 100, but he uses the population variance as the second number. So there's just a couple extra steps you have to do when you're doing problem solving. You have to take the square root of that to get your population standard deviation. I don't know if I said standard deviation over here on the bottom, that sigma is standard deviation, not variance. So this is a formula that you will see used in the book frequently.